What's up, everybody? I'm Matt Gary, and in this episode of Coding with the Fours, we're going to go over absolutely everything that you need to know to be able to create tests for your Apex classes in Salesforce. Alright, everybody, so today we are going to be going over absolutely everything that you need to know about writing tests for your Apex classes. We'll go over what Apex tests are. We'll go over, why they're important. We'll go over what unit tests are as opposed to integration tests. We'll go over just about anything you can think of, and of course we'll do examples over tons and tons of stuff. Also, before we get into the wonderful world of Apex test classes, make sure that if you enjoy this video to actually like it, because when you do, it helps it get out to more people just like you that want to learn this stuff for free too. So, enjoy the video, like it, and, maybe subscribe too, so we can hang out even more often. So, with that said, let's get right into it. So the first question is, what is an Apex test? Why would I bother to test my Apex classes? What is the benefit to me in general, right? I've already wrote the Apex. It was a lot of work. Why do I want to test it on top of that, It already took me forever to write the code. Why do I test it? Long story short, the reason that you want to test code is because on top of it being a safeguard for you as a developer, it's also one of the most freeing mechanisms that you as a developer can have in any ecosystem. Doesn't matter whether it's Salesforce or some other stack. Writing tests that are good, that you trust, is one of the most valuable things that you as a developer can have. And the reason for that is every piece of code that you write is almost certainly going to be changed over time, right? It doesn't matter how good you make it, the business will want to change it. In fact, the better you make it, the more people that use it, the more it will change. And if you change something, you want to know that all of the pre-existing work that you've done hasn't broken. It's not, introduced 10 new bugs into your system, right? So that's why we create tests. And then on top of that, as a developer, everything you write, you're eventually going to want to go back and refactor one way or another. And if you have good tests, you can go back and refactor whenever you'd like to. But if you don't have good tests, then you have to beg and plead with your product owner or business person or whatever for story points to go back and actually refactor your code, right? So, two main benefits. It makes sure that the code that you originally wrote always functions just the way that you anticipated it. And the second one is it frees you as a developer to be able to refactor and make, wonderful upgrades to your code whenever you see fit instead of whenever you get the opportunity to. The last thing is, of course, in Salesforce, you need 75% coverage at least for your Apex classes that you have in your org. So if you don't create these test classes, then you can't actually deploy your code into your Salesforce org, which is a wonderful thing that they've added. Although I will say, if you just go for 75% coverage, as we'll see through this video, it's not really going to be beneficial long term. You can get 75% coverage on your code and have terrible tests that do absolutely nothing. Trust me. So, with that said, hopefully I've convinced you that Apex tests, or tests in general, just test, Apex tests, testing your code, period, is worth your time. And now we're going to get into how to actually build out some of those tests together. Alright, so the first thing that we're going to do together is just create an Apex class, and we'll do it within Visual Studio Code. You can do this in any IDE that you want, but I'm using Visual Studio Code because, of course, it's free, and it's what most people will use these days. If you're not familiar with Visual Studio Code, don't worry, I've got a video that shows you exactly how to set up Visual Studio Code so that you can follow along with this tutorial. And you can click the link up above or in the description below, and go check that out first, so you know how to set up Visual Studio Code. It's pretty quick, pretty easy, not too big of a hassle, and it makes your life way easier as a developer. So with that said, first thing we're going to do is in Visual Studio Code, we're going to create an Apex class together that we can test, right? So we'll do Control-Shift-P to bring up our command palette here, and then we will use the create Apex class command, and we'll say, I don't know, demo class, because I apparently have no imagination today. We don't need the constructor for this class, so I'm just going to remove that for now. And we'll make a couple methods in here. They'll just be simple methods that we can test really easily together so that we can, you know, figure out how everything works. So we'll make a method, and we'll call it public. I'm going to have it return an integer, so we'll just say integer. Multiply numbers. I think I spelled that right. And then we'll just pass it in a couple numbers. We'll say integer int1, and then integer int2. There we go. And basically all we're going to do is just return the multiplication of these two, like so. And that's pretty much it. Now we've got a method in a class that we could test, right? And that's really all we're trying to do right now. We're going to get into some more complicated methods to test, like integrations, for instance, with external systems in just a little bit. But I want to start off really simple so that you just get a understanding of how these tests work. So really, really simple. We're just multiplying a couple numbers, nothing crazy. Now one thing I want to show you is, well, I'll show you it in a minute. I don't want to get ahead of myself. First things first, let's create our Apex test class. So we'll create an Apex class, and we'll just call it, the way I like to name my test classes is I do the name of my class, demo class, and then test. Personally, I like to do an underscore test because I think that makes it extremely easy to find. But I know that there's a lot of people out there that hate underscores in their class names. I totally get it, but I think it makes it easier to find when I'm looking for things. So I normally do the name of the class underscore test, and that way when you see them in your list of classes over here, they'll be right next to each other, right? So you don't have to go looking for them. You don't have to wonder what class is this test class testing, etc. So all right, so we've got or where to find the test class on top of that. They're right next to each other alphabetically. All right, so we have our demo class test class in front of us, but right now it's not a test class, it's just a regular class. So we need to declare it as a test class. So what we do is say @isTest up at the top, and this will mark it as a test class. And that way Salesforce knows this is a test class. This is a class that is going to be testing the actual real code that's running in our org. And yeah, and it treats it a little bit differently as well, which we'll go over as we work through some things. So we've got our demo test class, and we want to test our method within demo test class called multiply numbers, right? The way I like to make my test class methods is I just say, well, first we'll declare it as isTest, which you have to do above every test method. And you'll say public static void, and then I always do the name of the method I'm testing and then the outcome that it is giving me. So multiply numbers, I don't know. We'll just say, to keep it simple for now, positive outcome. Positive, you know, I'm just going to leave it at this. Multiply outcome positive. And we'll get into more about these positive, negative, etc. scenarios that you can test and how to name them and all that kind of stuff in just a little bit. There's actually another thing I like to do too, personally. Again, this is my personal preference. A lot of people will probably disagree with me, but it makes it easier for me to see things. If I'm doing a unit or an integration test, which we'll go over in a lot more detail later, I would say unit or int, because that way I know this is an integration test or it's a unit test, etc. All right, so another thing that you might see instead of @is_test up above here is a test method test method declaration like that. There's technically nothing wrong with doing this, but I typically don't use it. I don't know that there's necessarily any difference. Truthfully, I'd need to look into it. I have always used this because this is a more recent version. It's the version that's preferred by most people, so I stick to it. But if you are in an org and you're looking at test classes and you see that test method thing, test method declaration here, it works just the same. So, all right, on to actually testing things. So we've got our demo class, and my voice apparently can't handle talking at the moment, just keeps cracking or something. Maybe I'm 16 again. I sure don't look like it. Anyway, so we've got a demo class, and we want to test it. And so we're going to initialize or instantiate our demo class. But the first thing that we want to do is when we're actually at the point where we are truly testing our class or truly testing what we intend to test, you want to do this test.startTest and test.stopTest. And then you'll put your code in between. Now, if you're creating data before you run your tests, like say you're inserting some cases that you need to be able to run your test to actually run this code successfully, then you'll want to do that before you do test.startTest and test.stopTest. And the reason for that is test.startTest and test.stopTest make it really easy for you to see how close you're getting to limits with just what you're testing. You know, how many SQL queries are you executing for this one method call, right? Or, you know, how many DML statements are you using for this, this call to this one method? So make sure you wrap the code that you're truly testing in these test.startTest, test.stopTest. And we'll go over this again, but I was just going to do it right now, and I didn't want you to be confused about why I'm doing that, but we'll go over this in a little bit more detail in just a little bit. So we've got these here. We've got our test.startTest, test.stopTest to basically reset our limits and for us to be able to take a better look into the limits that we're using for each one of these methods that we're testing. And so then we'll say demo class. We'll initialize our class or instantiate our class. We'll say demo class, dim class equals new demo class. And then we'll say dim class dot multiply numbers and okay. And then we'll send it a couple numbers. We'll say 7 and 2. Right? And we'll want to assign this to an integer. So we'll say integer multiplied number equals that. And of course we should get back 14, right? Because 7 times 2 is equal to 14. Now if I run this right now, what you would see is that I would get over 75% coverage. I'd get 100% coverage with this test class. And we'll do that. So I'm going to save this really quick, and we will run this, and it will show us that we get 75% coverage. All right, and now that that has run, we can take a look at a couple things. The first is the testing area of Visual Studio Code, and you'll notice that we have a green light for these test classes that we just ran, or this test method that we just ran, really. If it had a problem, it would have a red light, and it would let you know, that indicating basically that you didn't run your test successfully. And then in this output panel here, you'll also see the code coverage for the test class that you just ran. And if it wasn't 100%, it would also give you the lines in your demo class, or your class that you're testing, that were uncovered that you should ideally go back and cover, right? But we have 100% coverage, so that's great. That said, that doesn't really test all that much, right? We have now successfully essentially tested that our class will run, and the method that we are testing will, I guess in general, just execute, right? But we haven't actually tested whether or not our return value will actually match what we anticipate, right? So we are passing in two numbers to multiply, 7 and 2, and we know that 7 times 2 equals 14, right? How do we actually verify that our class did the calculation properly and returned it to us, right? So there's a great way to do that in Apex that unfortunately too many people do not use, and I hope that you won't be one of them. Because this is how you start building tests that you can trust. This test does very little other than just run the code. It doesn't test to see whether the code did what it's supposed to do. But now we're going to make it so that it tests to see whether or not the code actually did what it was supposed to do. And so what we're going to do is say assert r equal, and then we expect our output to be the number, oops, not 12, but 14. And our actual will be our multiplied number, this guy, right? Our variable that we assigned here. And then our message, if we get it incorrect and things aren't equal, we didn't get the value back that we anticipated, would be whatever you want it to be. It can be any string you want, but I like to add these messages. The returned value was not multiplied correct, or something along those lines, right? So now we have a way to actually verify that our code did what we wanted it to do, what we thought it was going to do. And so we'll save this. And after it deploys here, we will run this test. And hopefully, if I can do math right, which is a big question mark, then it will come back as 100% covered, right? We won't get any errors. It looks all good. Great. So even though we made that assert, now we know, because we made that assert, that we are multiplying our numbers correct. However, right, if we put in another number, like 10 here, which we know is wrong, right? We know it's wrong. This assertion should fail. So now that we have deployed that, we can run the test, and then we can see its failure, I hope. Great. So we can see that the test did fail, and we can see that why it failed up here. And it says the assertion failed, the return value was not multiplied correct. And that's because our expected was 10, which we put in there ourselves, and our actual was 14. So actually it was multiplying correct, but we intentionally failed that assertion so that we could take a look at what happens, right? Okie dokie. So now we know what assertions are and how to really test our code. You know, at least some simple code here. We'll get into the more complex stuff in a little bit. But now we know how to really verify that our code is doing what we want it to do in our test classes. And you'll also notice that I put the assertion outside of the test.startTest, test.stopTest. And again, that's because all code that is not directly related to what you are actually executing to test your functionality, the functionality of your code should go outside of that test.startTest, test.stopTest, you know, of those parameters. So, or statements, actually. Anyway, so the assert should go outside of that too. Technically, you could put it inside. It's not necessarily going to hurt much of anything at all, but I always keep them outside because they're not really part of what I'm executing. All right, so with that, it's time to get into some marginally more exciting stuff now that we've gone through the very basics. All right, one more thing that I just want to go over just so that you know that it exists before we get into the next part, which is going to be about creating all of the data that you need for your test classes to execute, is that you might also see in probably the vast majority of Apex classes the system.assert instead, or some variety of that, because there are multiple asserts, assert equals, assert not equals, etc. You might see that as well. And that's because up until maybe a release or two ago, I can't remember, three releases, it's actually been a little while. That's the way that you used to write asserts in Apex. But then they created their own assertion class, or the assert class, and so now you should be using that assert class. So there's not necessarily anything wrong, again, with system.assert, but the new assert class that they have is built specifically for assertions, and you can see that it has quite a bit more functionality than that system.assert does, right? So always go with assert. If you see older system.asserts in your test classes, it might be beneficial to switch them because, again, you get kind of some added functionality and it's a little bit cleaner. All right, so with that said, it's now on to a little bit more challenging of a test, one that requires us to create actual data to send into the system to actually test. You know, that maybe a case record got created or a case record got updated, or who knows, whatever, right? So let's give that a shot. The first thing that we'll do is we'll just create another method in this demo class that I've been using, and we'll call it something, I don't know, public. We'll have it return a case. Actually, no, we won't have it return anything. Public void case updater, and we'll pass it a case to update, and we'll take that case and we'll say case.subject, oops. Cool story, bruh. And then we'll update case. Oh, that's why I'm. There we go. Okay. Let me make sure subject is correct. I think it is. But yeah, it's just not. It's just not auto-populating I've gotten spoiled by IntelliJ, but I do Visual Studio Code because I know more people leverage it. Anyway, all right, so we've got a case updater method, which means that we need a case to already exist for us to be able to test that this case updater works, right? I mean, ideally. Because we'd be passing in a case to update, and then it'd update the subject line, and then it would actually update that case. So, what what do we do? How do we get a case in the system already to test here? And as we'll see in a little bit, you can actually do this without putting a case into the system, which is kind of a little bit where unit testing comes into play. There's a little bit more to it than that. But in the meantime, if we wanted to do what's referred to as an integration test, where we truly insert a case and we truly pull it back and update it, how would we do that? And there are a couple ways to do this, right? The first one is you could just create the case in your test method, which we would need to create another one. So we can just kind of grab this, save myself a couple seconds here. Maybe, no promises. And I need to put an is test on top, like so. So now we've got our test method. We could just create our test case data all right here, right? We could say case, new case equals case, and then we could give that case all the information it needs to exist. Subject equals hi there, etc. If you didn't know, you can pass all of the fields into the constructor of a object. But the other I clearly need to go check what fields are actually on case, because my brain is either letting me down or this IDE is making me okay, there's definitely a subject. Okay. All right. So we can create a new case in here, right? And we can actually insert the new case here. And then we could take that case. We could initialize our demo class again, just like we did before. And then we could say dim class dot case updater and pass in the new case, like so, right? And then, of course, just like above, we still want our test dot start test and test dot stop test, just like that. And you don't have to indent, but I like to indent in between these. It makes it easier for me to know what I'm doing, I guess. And you could create all your case data here, right? But there are better ways to do this, and I'm going to explain a couple of the ways to do this and why there are better ways. The first reason that there are better ways is because chances are super high, if you need a case for a class that's not a demo class that I'm just making random junk up for, you would probably need a case for the vast majority of the other tests for that class. So if I'm creating a case in every single test method, that means in the future, I'm going to have to go, if I need to change something or something about that class changes, and I need to create the cases in a different way, that means I have to go into every single test method and change my creation of a new case, right? Not great. So there are a couple ways to deal with this. The first is you can use test setup, but even better than that, there's something called a data factory or a test data factory that you can create so that you can essentially have an easy way to generate data for your test classes. All right. So the first thing we'll look at is the @test_setup method, which you can use. And I'm going to go over all the very specific details of @test_setup because there's some really unique things that happen with test setup and test classes in general. So we'll do @test_setup, right? And it's already going to just give you something, a method already. But basically what this test setup method does is it allows you to create a method that runs automatically before each one of these test method runs. So and I think people get a little bit confused about this because I think that they believe, or they're under the impression, that when you create a test setup method, it just runs once at the start of your test class execution. And that's actually incorrect. What test setup does is it runs once per test method. So if your test class has 15 test methods in it, test setup will run one time for each of those methods, so it would run 15 times. Basically, the way that a test class works behind the scenes is for each test method that runs, at the end of the execution of that test method, everything resets. It basically erases everything that you've created in those test methods and resets itself. Right? Once this method is done running and it started to run this next test method in this class, anything that happened within this test class, or this test method rather, would be deleted and reset, and then essentially a new execution would start here. And so what happens then is if you use a test setup method, it runs every time before the start of a test method. So it's a tough day for me, voice-wise. Anyway, so we've got our test setup method. We can leave it at make data. And what we could do is we could create that case up here in test setup. And then what that would do is if I execute my test class, for each test method run, it's going to create this case. Perfect. Now the difference, though, is that there's no context to this new case in here, so I would have to now, in my test method, query for that case. So I'd have to say case, or rather list of cases, case list, like so. And I could even say where subject equals hi there to be even more specific. Like that. And then I'd have to take my case list and say case list 0, right? So that's kind of the difference between what you'd have to do. You'd create your data up here and make data, and then it would make that case before multiply number position before that test started. Then it would delete it, essentially. It would actually delete this case after it finished executing, and then it would create the case again for this one, and then it would delete it after it's done executing, and then etc., etc. Now it's really important to know that test setup works this way, because if you get into some more complex integration tests, which, hopefully you kind of go the unit test route if you get this crazy, but if you get into more of these complex unit tests, you might start seeing yourself run into different limits. And often it's because people put way too much in this test setup method, where they're creating a whole bunch of data for literally every test method that they have, when there isn't actually a point in doing that for the majority of the methods. Maybe you create data for every single test method, and 60% of that is only done in one method, right? You only need 60% of that data for one test method. So it's really important to know because it can push up your limits really, really high. But that said, just be careful with it and know how it works. And typically only put things in here that the vast majority, or at least the majority of your tests methods are actually going to use. So this is cool, right? Now we have this test setup method that can create data for us at the start of every test method run. But what if we need to generate the same data for tons of different test classes? Because if you get into a big enough org, or as your org grows, if it's small right now, you're going to see that more and more often, test classes that aren't this one we're making right now are going to need cases created for them too. So how could we do that, right? And the answer is a test data factory. And so what we're going to do is basically create another class. So we'll do Control-Shift-P, create an Apex class, and we'll call it our test data factory, like so. And we'll put it there. And now that we have our test data factory, what do we do with it? So what we'll do is we will say public static, and we'll return a list of cases. And what do I want to name this? Create cases, like so. And we can do something like integer num cases. And, we could pass in anything else that we might want to. And then basically what we'll end up doing is we will iterate through that number of cases that we want to generate and send back a list of cases. So what we'll do is we'll say for integer I is equal to 0, I is less than num cases, I plus plus. Oops, less than or equal to. Actually, I'll just leave it at that. So, I put a comma instead of a semicolon. Okay, so this is an old-fashioned for loop, basically, but it comes in handy here. And basically what we're going to do is we're going to create a list of cases to return to our class, our test class that wants to create cases on our behalf, basically. So we'll call this case list equals new list of cases. Whoop. And in here, we'll say case CS, maybe new case is equal to new case, and then we'll just make the subject equal to awesome case. And then we will put this in the case list, like so, and then we'll return our case list, right? So basically now we have a dynamic way to create as many cases as we want. You could, in theory, create 6,000 cases and have it get returned to your test class. And now what we can do after I save this, maybe, then we can come over here to our test setup method, and instead of creating our cases this way, what we can do instead is say test data factory dot create cases, and then send it maybe 3 cases, right? And that is going to allow us to create cases, and we can just call this in any test class to create cases. And of course, you can make this a whole lot more useful by maybe passing an object that has case values or more information that you'd like to actually build out for this case. But this is the gist, the general idea of a test data factory. Now we've got this really useful tool that can create our objects or our data for us very easily whenever we need it to, right? And so now, if we come down here, let's finish this case updater test method by creating an assert. And we want expected equal, and I think our expected outcome was cool story, bruh, for the subject. And we'll see what our actual was for this return value. If I can spell. And if it's not right, we'll say subject not updated appropriately. Or something like that. It's a big word. Anyway, there are a couple other things I need to do before I actually run this test, though. Now that I'm thinking about it, the first thing is our subject is now awesome case, so we need a query for that. And the second thing is, which I forgot to cover, you might have noticed it and might not have, but in the test data factory, I don't actually insert these cases because I don't know what somebody's going to want to do with them, right? They might want to insert them, they might not. So it's always best to not make that assumption for whoever is running this test data factory, and instead allow them to make that decision on their own. So now that you've created all the cases, we actually have to insert them or nothing's going to happen. So we would do list of case list is equal to test data factory, and then we can say insert case list, like so. And now, if we save that, it will actually allow us to run our test and hopefully get back some positive results. We'll see. So let's click run all tests and see what happens. So it did run successfully. That's great. So we know that it ran the test because we actually inserted cases, ended up testing some other things too, which is great because now you can see how uncovered lines work and what gets returned by everything and all that. So what we can see here is that our make data method did indeed work for test setup. So that test setup did run before our individual test method, and it did create our cases, it did insert our cases, and most important of all, our test or our class actually did update the subject line to cool story bruh for our case list, which is wonderful, right? So now we've learned a whole bunch of really useful stuff, in my opinion. We've learned about how to create test data, how to use test data factories, and now that we have figured out how to use test setup and how to create our own data and how to assert things and how to do so much, now we're going to go over all of the little minute details of tests, like should you test private methods, and if so, how do you test them? We'll also go over how to do mocking for integrations. And then we're going to go over unit tests and integration tests, and we'll do one demo, short demo of a unit test. If you want more information about unit tests than what I'm going to cover at the end of the video here, I have 2 very long videos over it. So if you want more detail about unit testing, I do have that available, and of course I'll link it just like everything else. So now that we have got really some of the most core aspects of creating test classes done, again, we've covered Test.StartTest, what it means, how to create a test method, how to create a test class. We've created how to create your own, or discussed how to create your own test data, and how to use the test data factory and why you'd use it. Now we're going to go over a handful of other things. So let's get to them. Okay, so the first thing is, before we veer off too far from this test data factory stuff, there are also other ways of creating test data, and there are also other ways of pulling data into your test class. And I just want to go over a couple of them and discuss them with you. First off, you can create a static resource and pull in that static resource to generate data for your test class. This is personally something I don't very often, if ever, do. I kind of prefer to have the test data factory so that I can manipulate things whenever I want to. There are certain situations, though, where you want the exact same data to be created all the time, and maybe you want it to be easier for someone like that's not technical, that isn't a developer, to go up and modify that data. In that case, maybe you make an Excel sheet and upload it as a static resource and generate your test data that way. There is an option to do that, but I'd say its use cases in practice, at least in my experience, are very limited. So there is an option to do that. I'm not going to go over that in this video, but I did just want you to know that that option does exist. The second thing that you can do to generate test data is you can say SeeAllData equals true. And so what this means here, SeeAllData equal true, is that now your test method doesn't need to create any test data at all, right? It can see all of the data in your org and run tests using the data in your org. But I would advise against this almost always, except for the very unique situations in which you must use it. For instance, with the Connect API or Chatter, you have to use SeeAllData equals true. Kind of awful, but you do. But in 99% of situations, you don't need to do this. And I would never do this. And the reason for that is data is not going to be the same in every org. So you're making an assumption, basically, by using this, that in every org some data is going to exist, which is just not true, right? In your developer orgs, the data between your developer orgs or your QA orgs, UAT orgs, and production orgs, it's going to very widely vary most of the time. So if you're using SeeAllData equals true, you're making assumptions that just will almost certainly break at some point in time. Not to mention, it's just not a good idea in general to be, pulling that data in a test class, right? It's not like it ever commits data in a test, but it's just not in your best interest. So if you see this, except for, again, those very rare situations where something like the Connect API absolutely needs SeeAllData equals true to be able to test it, never use that. You'll see it as an option. You'll see it in the documentation. You might even see it in your test classes, in your org, but please don't do it unless your test is it is mandatory for your test to run. Okay, so those are the couple other things I want to go over regarding generation of data. The next thing is we've only been testing public methods in our class. What if we wanted to test a private method? Maybe there's a private method in here that the case updater calls that says, you know, private void update case description or something like that. I don't know. And this method, case updater, calls update case description. And for one reason or another, you're very determined to test this private method individually. What you could do is use the @TestVisible annotation to allow this method to be callable from a test class. So normally, right, a private method, if you initialize a class, our demo class here, normally a private method is not callable externally. You couldn't say demo class dot update case description, right? You can't call it. And because I haven't saved yet, you can even see that it won't autocomplete for me, right? But after I save and I make that test visible, then you will be able to call this private method and test this private method within your test class. Now, what I will say is that on occasion, you really truly do need this functionality, but it is rare. There's a lot of code out there where people will make every single private method test visible, and it's really typically not necessary because private methods only exist typically to be called by one of the public methods, right? So generally speaking, the only methods that you want to test within your test class are the public ones. Once you start testing your private ones individually, it kind of tests them a bit out of context. So I normally don't advocate for testing private methods on their own, but you will find situations in which it is better to test the private method on its own, maybe because it is a more complicated method or it's a method that you heavily depend on for the rest of your code to run independently. And if so, use that test visible annotation to really hone in and test that private method exceptionally well. But at least 80% of the time, maybe even more than that, maybe 95% of the time, you don't need to do this. But it does exist for you if you have a real circumstance in which it would be beneficial to you. All right, now that we know all about the test visible annotation, we should go over one other thing that you're going to see pretty often that I would suggest people don't use, but you very often see people use to cut corners, among other things. Now, there are situations in which you actually do need to use this for very specific circumstances. Like, for instance, I mentioned Chatter and the Connect API before. I think there are circumstances where you might want to use what I'm going to show you for that. But there are certain situations in Salesforce where this actually is necessary. But again, kind of like the SeeAllData equals true, you want to use this only when it's actually mandatory. My contact just attacked me, I think. Okay, so there is a method that I see used all the time in the test class called Test.isRunningTest. And what this allows you to do is in your regular code, not your test code, but in your regular code, determine whether a test is running and then do something different in your code because it is running, right? And you can already kind of tell just by me stating that it's not ideal, right? Because you don't really want your test in 99.9% of situations to do anything different than your code would do normally when it's operating. But you'll see this done all the time to get around, code coverage issues, or maybe catch statements that are difficult, or whatever else, right? So, this exists, and you can often, what you'll often see is someone say, if test is running test, do this thing, and then otherwise execute the code the way that it normally would execute. So for instance, maybe for some reason, if test is running test, I want the case subject to not be cool story bruh, I want it to be Taco Tuesday or something like that, right? So you'll see this a lot. I just wanted to point this out because it's extremely common. Unfortunately, I say it's extremely common, unfortunately, but it also is something that you'll need to know exists for very specific situations that you might find yourself in. Like I said, use it sparingly, but it'll give you that option to kind of divert from your normal code in a test scenario if you need it, right? Okie dokie. So, before we get into a handful of the more specific things, like creating or doing mocking for integration tests with a call out to an external system, and then for some things around event buses and batch classes and stuff along those lines, and then unit testing. I just wanted to go over a handful of best practices when you're creating your tests, and then we'll get into all that other wonderful stuff. So we've already talked about a handful of them, right? And I'll just go over those again. First is, don't use SeeAllData equals true for your test methods unless it is absolutely mandatory, like I mentioned, for things like chatter and the Connect API, as well as a handful of other things. I feel like chat, or used to be called live agent, requires it in some situations. But don't use it unless it is mandatory. Second thing is, make sure to use a data factory, a test data factory, to create your test data, right? You don't want to be updating the creation of your data over and over and over again in what will eventually become, I promise, hundreds of classes. So make sure to use that test data factory to create your data. Make sure in test setup to only create the data that is going to be used in the vast majority of your tests, right? That's very important. Otherwise, you might end up pushing up your limits for this test class, unnecessarily. So, third, make sure to name your test class appropriately, right? Am I on 3 or 4? It doesn't really matter. Next thing is, name your test class so that it's easy to find and that you know what class your test class is actually testing, right? So make sure to name that class demo class underscore test, or just demo class test, or something that makes it easy for you to identify that. Fourth is our naming conventions for our methods, which is the name of the method you're testing, the type of test that you're doing for it. Is it a positive outcome? Is it a negative outcome? Are you catching a, are you testing a try catch, or whatever. So make sure that you name your methods after the method you're testing, and specifically the scenario that you're testing, because it'll make it easier for you to come back and know which methods are testing what. Fifth year is your test.start test, test.stop test. Make sure that you use these around what you are truly testing, so that you get a good understanding of the limits that are invoked and the things that are done for this specific method that you are testing at this moment in time. Sixth is that you want to make sure that you assert everything that you need to assert. Positive, negative outcomes, etc. Without asserts, test methods are basically useless, right? So make sure that you incorporate them in every test that you do. The seventh thing that I want to go over here is that you might have noticed that when I was creating these test methods, I'm only testing one thing in these methods, and that is exactly what you should do too. Your test methods should not be testing a whole bunch of stuff in a single method, just like your methods, if you're creating them correctly, shouldn't be doing a whole bunch of stuff inside of them, right? There's this concept called the single responsibility principle, which I think I have a video about if you want to go think about that whole deal. But basically the idea is that a method does one thing, or more broadly, the general concept is what you are, if you're building a method, it's only doing one thing, and it's not doing a whole bunch of things. And the reason for that is it's easier to understand, it's easier to deal with in the future, and it's not so difficult to alter when you need to alter it. So when you're creating a test method, that test method should only test one thing, not all 50 combinations of tests that you might want to do for a single method, which you wouldn't want that anyway, but the 3 or 4 or 5. So make sure that your test methods are only doing one thing at a time, because it just makes it easier for you in the long run, and those that come after you. And I'm sure there's plenty of other things that could be said here, and there's a few more things that we're going to think about when we get to unit tests and integration tests a little further down in this video. But that's kind of the gist of best practices here, at least on a very simple scale. And hopefully those will help you make test classes that are easy to follow and easy to maintain and upkeep and all that. So, all right. Next thing, we're going to get into integrations and how you actually do callouts, those mock callouts to endpoints, right? Because in our test classes, we can't actually call out to a REST endpoint or SOAP endpoint, or whatever you're calling out to. You can't call out to it in a test class. So we need a way to essentially fake that interaction, right? And so I've got this old class that I made a long time ago now. And it does a call out that I'm 100% sure doesn't actually work anymore, because I'm pretty sure I've deleted all of the things that would make this work. But the general idea is here anyway, right? We have a call out that would call out to somewhere. It looks like I was actually calling out to Salesforce itself, which is not really relevant. But if I tried to call this class in my test class, it's going to tell me that I can't do a call out to an endpoint within a test. And but as we previously discussed, we need at least 75% coverage on every class that we put into this org, or really you need 75% coverage for the entirety of the org, which leads to a whole bunch of workarounds and bad practices, but let's just not get into that and pretend that you need 75% coverage on every class. So if you're going to cover this, you have two options, right? You can actually try to test this legitimately, or you can do what you'll see all the time, which again I just mentioned was not a good idea, where you could say if Test.isRunningTest, don't actually do the call out, do something else. But again, don't do that. I guarantee you'll see it in probably more than half your code bases though. So let's figure out how to actually mock this together so that you can do it the right way and everybody will be so happy and thrilled. Of course, I didn't want to run a debug test, but I clicked it, I guess. Okay. Wow. It's really... There we go. All right. I actually did want to deploy, but I'm getting confused by that. Anyway, here we go. So let's test this post callout. So we're going to create a new test method, and I did not, see, this is why I don't use Visual Studio Code all that often, because I still think its autocomplete is not spectacular, and often gives me what I don't want. Anyway, I complain about Visual Studio Code. I'm just happy it exists. Thank you, someone, for making this and making all our lives easier. So our method that we're going to be testing, and again, what I'm about to do here is actually bad practice. You're testing a method in a different class than this demo class, which is what this test is for. So maybe I should just actually create a new class here so I'm not pushing bad practices. And we'll call this post example test, like so. So now we've got our new test class that we're going to use for testing that callout. And the next thing that we're going to do is create a method. So we'll say public static void. I first need to make it is test. Public static void, I don't know what I made this method name. Send post request. Like so. And then we'll just try it, right? We'll try to do this call out and see what happens. So we will create a new, or instantiate a new version of this class. So we'll say post example equals new post example, and then we'll say post example dot send post request, like so. We'll just see what happens. And again, make sure we're doing test.startTest and test.stopTest to make it oh my god, oh, there we go, to make it real nice and good. Okay, so if I save this right now and deploy it and I run this test, it should give me an error. Hopefully it's the one I anticipate and not one saying, this is 900 years old at this point, a couple years old, but Okay, so as you can see, or maybe my head's in the way, so let me just raise this up a little bit. As you can see, it says it failed. And it failed because methods defined as test method do not support web service callouts, right? Like I just mentioned. So when it reaches here, where it's trying to actually send out that request, it's failing. And we need a way to essentially fake that. And we're going to do that using the test.setMock method that allows us to essentially create a mock response for our callouts and use those mock responses to return a response to us in the code. So let's check that out. First thing we're going to do is create yet another Apex class, and we'll just call it, I don't know, post example mock generator or something like that. And this has to implement the HTTP callout mock. So for this class, you're going to say implements HTTP callout mock, which is going to indicate to Salesforce here in a bit that we are, essentially creating a fake or a mock callout. And we don't need this method, but what we do need is to do a couple of things. Make this global and create a global method in it that returns an HTTP response. And this method is called respond. It takes an HTTP request, which we'll go over in a little bit greater detail as we work through this, so just stick with me. Okay, so we've started on this HTTP callout mock class, and basically what we want to do is generate a real response from our callout, right? So normally when this calls out, it's going to receive a response. As you can see here, HTTP response, HTTP send. When you send that, it's going to send you back typically a JSON body, sometimes an XML body. And we need a way to fake that interaction. When we send our request, we need a way to fake that response. And so that's what we're doing here. So we're going to send it a request, which we'll see here in just a little bit. And when we send it that request, we are going to be expecting this response that we're making right here. And so when you make these tests, when you make these responses anyway for these test methods, you're going to want to try to make them as realistic as you can. So you will likely know when you're doing these integrations what a response would look like for a given request. So you should strive to replicate a realistic response value. And again, you'll know what that looks like based on the integration that you're doing. But really important to know, you should definitely try to strive for a realistic response, not just an easy one, so that you can really test your code out really well. Okay, so what we're going to do here is create an HTTP response. And we'll name it response, new HTTP response, like so. And then we'll want to test a handful of things, right? But the most important one is the body, right? So we'll want to set the body of this response. Oop. And this is where you'll set it to, you know, whatever you would expect. Typically, this is what you care about quite a bit more than anything else. There's some situations where that's not true, but typically the body of the response is where all the good stuff is that you want to test, or you at least want to be semi-realistic. So, oops. So within here, we'll say, you know, I don't know, post response, and then we'll give it a response of hi there, right? And then we'll return this response. We can set a couple of other things too. You can really set whatever you want on this response. As you can see, there's a lot of things that you can set like status code, the body, the header, lots of stuff. So I'm going to also set a status code of 200, just so that we know that it's a successful response. That's what a typical successful response code is. And we will leave it at that. You could also set headers. Oftentimes you'll set a header at the very least in here, but this will do for now. So now we've got a fake response. Oops, I meant to do set status code. Cool. All right, so we've got this saved. Now we need to actually utilize this in our test class, right? So how do we actually utilize it in our test class? We're going to use the Test.setMock method. And so we'll do that in here. we'll say test.set mock like so. And then the first thing that you are going to pass in is an interface type. Your interface type is this class that your class you just created implements, that Salesforce has created on our behalf, which will be the HTTP callout mock. So you'll just say HTTP callout mock.class. And if you don't understand that, don't worry about it too much. It is a relatively advanced topic. I have some videos over that if you want to go check it out. You can find it in the design patterns tutorial series. What was I thinking about? Okay, test.setMock. The next thing that you need to do is actually initialize a new version of your class that you just created. So we'll say example mock generator like so. That's the class that we just made here, right? So now we've set this mock. And now that we've set this mock, we can run this test, and it should run successfully. So we'll hit run all tests, and we can see they did successfully run, which is pretty cool. And we got 100% coverage, which is great. And basically what's happening, just to explain this one more time because it is pretty confusing, especially the first time you do this. When you set up this test.setMock, when we get to here in our callout, right down here, where we're actually sending out that request, what we're now doing, instead of truly sending it, out into the World Wide Web, that feels weird to say. I don't think I've ever said it that way. Instead of sending it out into the real world, it's going here to our callout mock, and this is receiving that request, right? That request that you see here. This is receiving it, and then it is, returning a response to us. And right now, I'm not returning anything for this, but let's just return that response really quick so that we can test that it came back. Actually, let's just return the string, and we'll say return response.getBody, like so. And I'll comment this out here because not super important. And then we will go back over here and we'll assign this to a variable just so that we can see all of this is actually working. You can kind of tell because it actually successfully ran, but let's just prove it out, So we've got a string called response. We'll just call it response. And then we'll do an assert r equal, and we'll put the expected there in just a second. Oops, not what I want to do. And this should be our expected string, I believe. And then we can say callout response was not what we expected. All right, so now we've got an assertion, saved post example, we'll save the test, and then let's run this again and see what happens. I might have this string wrong, but we'll see. I didn't, which is great. So we can see that it indeed did give us that response that we provided in our mock generator here and output that to us, and our assertion verifies that, right? So if I change this even one character to like that, for instance, it should fail, and we'll just run this just to verify that it is that it would. And it does fail because of differences in the response, as you can see. So pretty cool and pretty a pretty simplistic thing to use to test your callouts quite a bit more realistically, right? Obviously, the more complicated your callout is or your integration is, the more complicated that this gets. This is a very simple implementation because I don't want to waste literally hours going over all the varieties that you might get yourself into. But this is the basis on which everything else kind of stems from that you'll get yourself into. So this should give you the groundwork for any of the difficult things that you'll find yourself dealing with, whether it's XML or JSON or REST or SOAP or whatever, right? So with that, I think the other couple things that we need to talk about are unit tests, how to create a unit test, which we'll go over here in a little bit, when to use unit tests instead of integration tests, and then before we get into those, I'm just going to really quickly go over a handful of other test class methods that are beneficial that you know exist. I'm not going to take the time to go over every single use case here, but I do want you to know that they exist. So really quick, I'm just going to go over a couple of them. So we've got quite a few methods within this test class here, right? It sounds weird, but there's a class that Salesforce has made called Test that gives you all of these very useful methods to make your testing in your own test classes easier, right? And one of the major, a few of the major ones that you're going to use relatively frequently, or somewhat frequently, are in queue batch jobs, get event bus, and set current page reference is one that you use quite frequently. And then there's the test sandbox post copy script ones as well. So it's good to know that all of these exist because, for instance, if you want to test some aspects of batch jobs, you're going to want to leverage this in queue batch jobs. Same thing for get event bus or enable change data capture. If you're using and you want to test change data capture in your org, make sure that you leverage that method. Same thing for get event bus, right? If you're using events at all, then you're going to definitely want to leverage that in your test classes to test them accurately. Of course, there's some other wonderful ones like get standard price book ID, as well as tons of others. But I'm not going to go over each of these. I just want you to know that these exist, especially for those event bus related things, change data capture. If you're getting into that, you probably don't need me to go over that in detail, but know that they exist so you can test things. Same thing for if you're doing a test sandbox post copy script. So if you're doing those sandbox scripts and you want to test them appropriately, you really want to make sure to leverage this method because it's going to allow you to test it a whole lot more in depth, I suppose. So really important to know that these exist. If you want to see all of the methods and get more information about them, then of course Salesforce has got great documentation on it. But I did just want to at least call them out. This video is already probably pretty long, so I'm not going to go over every single one. But when we get to those specific videos, I will do my best to make sure I remember to show you how to test those things as well. All right, last thing before we get into the wonderful world of unit testing and integration testing, or the differences between them and what unit testing actually is I wanted to talk about running your test as a particular type of user. So this is particularly important for integration tests because the integration tests, the ones that we've been doing this whole time, which again I'll explain in just a little bit what the difference between that and a unit test is. The difference, or the importance of it is, these tests are going to run as an administrator unless you tell them to run as a particular type of user. And more often than not, it's not super beneficial to know whether or not they run successfully as an admin. It's much more important to know whether or not they run successfully as a particular user type. So when you're creating your tests, there is a unique method that you can use within them that allows you to actually test as a particular type of user. So what you would end up doing, and I'm not going to go into great detail about this, but I do want you to know it exists, and I do want you to know that it's important to take into consideration, is when you're running your tests, you can create a new user, right? So you'll create a new user, you'll assign all the appropriate permissions to that user in your test class, right? You can do that in your test data factory. You'll create a new test user in your test data factory, just like we created those cases. And then once you have a user created, you'll say system.runAs, and you'll pass it a user. So I'll just, for now, pass it a new user like that, and it'll be happy. And then you'll put curly brackets after it. So basically what this will do now is if I'm running this, I kind of want it like this. Like so. At this point, what the code is going to do is it's going to run this code within this block here as the particular user that I have created, right? And that's super powerful because it allows you to know whether or not that user has the right permissions, whether or not they've been, or whether or not your code is going to actually run successfully for that particular type of user based on the security that you have in your code and the security that you've set up for your user. So it can be extremely useful. And this is particularly important when you're testing things that are extremely heavy in user-facing, things that you maybe built for an Experience Cloud site or things along those lines, right? They can be for internal users too. But the more user interaction that you have with a particular piece of code, the more important it gets to potentially run that code as that user in your tests to make sure that if somebody updated a user's profile or a permission set, that didn't accidentally make it so that your code no longer works, right? So just so you're aware this exists, it is here. You can only use this in tests. You can't use this in your code, in your regular Apex code. And it is an extremely powerful tool to get very accurate testing. So make sure to leverage it whenever you can, so that you can trust your codes or trust your test even more. Oh my, yeah, that makes sense. I've got this in a block now, so it doesn't know it exists down here. That's fine. Okay, so last thing we need to do is talk about unit tests versus integration tests. And I've left this for last because it's probably the most complicated topic that you'll get into for test classes in particular. Because unit tests take a lot of prep work to be able to leverage. Whereas integration tests, you can kind of just create them no matter the circumstance with your Apex code. But unit tests require a little bit of prep in your Apex code to be able to make them work, and they're a little bit more of a complicated concept. So I wanted to give you all of the basics before we got into all of this complicated stuff. But first, what is a unit test and what is an integration test? An integration test is what we've been building this whole time, right? Where we are actually, for instance, creating cases and inserting cases and updating cases and querying for cases in this case here. And in an integration test, all of those things take place. The things that also take place in an integration test is if my demo class here, for instance, if it called out to, say, my post example test that we also tested just a little bit ago, and it created another class like so. And we called to a method in that. We called post.sendPostRequest. Then those interactions would actually take place, right? So an integration test means that you're not just testing this class in reality, and you're not necessarily just testing the methods in this class. You're testing the method in this class plus all other methods and database interactions that it relies on. Whereas a unit test doesn't do those things. A unit test is not going to test this a real call out to this code. And a unit test is not going to actually update your cases or do a query to the database. And it does this through, you're able to essentially fake these interactions or make it so that they don't really occur through something called dependency injection or through the use of the factory pattern. And we'll go over both those in just a little bit, a little. I go over them in great detail in a different video, and you can check that out if you want. So you might be asking yourself the question, well, how is that beneficial? If it's not actually calling the database, if we're not actually calling all the other things, why would I ever even want to do that, you know? And the answer to that question is two things. Number one, speed. If you're not doing database interactions, if you didn't know, database interactions are extremely time consuming. So, you know, one hit or one call to the database could take a couple seconds. It could take 5 seconds. It can take a long time to actually execute. And the second thing is, despite what it might seem with these very simple classes in front of us, you will get much more accurate testing for the particular method that you're testing with a unit test as opposed to an integration test. And like I said, that doesn't look obvious here because this is such an easy method. But if I made another method, for instance, and that method was a public method, we'll say it, we'll just call it example method, so I don't have to waste your time thinking about it. And within this example method, it had an if statement, and then that if statement had another else if off of it, and then within there was an if statement. And again, hopefully you don't really do this actually too often in your code. There's better ways to handle that, but but you can see there's a whole bunch of if statements, and maybe there's more nested if statements in here, and maybe there's an else statement in here, and then, you know, maybe there's a try catch block at the bottom of this whole thing, right? Like so. Well, now just this one method on its own, disregarding anything else it calls in any database interaction, has 1, 2, 3, 4, 5, 6 scenarios that you need to test. And if you're doing a database interaction or calling out to all these other things to do their jobs as well, it becomes harder and more time consuming to test every single one of the permutations of this class, right? Instead, if I eliminated all those things from the equation and could just test the logic in these if statements and in our try catch block, I would be testing something that was very important to test at a much faster speed and probably a lot more accurately, you know, for those minute details anyway. So that's really where unit testing comes in, is it allows you to hone in on this particular class's method only, and the logic in this particular method only, not other classes, not in your database, not in your validation rules or duplicate rules that run or anything else along those lines, right? This really gives you the opportunity to hone in truly on the method that you are testing and test it fast, right? Typically, unit tests are 10, if not 100 times faster than integration tests. So that's why we do them. That's why I'm going to waste your time showing you one quick example. And that's why you should probably waste your time after this, after you get a good handle on regular test classes, to go watch the other videos where I go in extremely deep detail over everything related to unit testing. So now that you've got that wonderful spiel out of the way, let's get into the actual code. Alright, we're back, and I've got a handful of things set up to briefly explain the concept of unit tests or mocking. Now, I'm just going to briefly go over this because if you haven't seen it, I have a video that's like 45 minutes long over this, but I do want to just give you a general overview of what mocking is and what it takes to get it implemented, right? So the first thing that you'll want to do if you're going to go down the route of executing unit tests and doing what's referred to as mocking, which again seems complicated. I promise it actually isn't after you take maybe an hour to learn it. Maybe a little bit longer, maybe a few hours, maybe a day. Depends on how long you've been doing development. It could take quite a while, right? First time around the block for me, it wasn't the easiest thing. And it won't be for you. So if you want to go down this path, which again I would recommend, especially for larger orgs, this is extremely important for larger orgs to adopt. If you want to go down this road, the first thing that you're going to want to do is create some kind of service or a kind of class to assist you in that mocking. And thankfully, there's a lot of open source libraries that exist. There's Apex Mocks, which is one of my personal favorites. I'm a very big fan of that library and the Apex Common Library. But there are other classes that don't require so much extra stuff. And one of the best ones out there is Universal Mocker by Suraj Pillai. I believe that's how you say his name. And if it's not, I'm very sorry. But but I am also very thankful that you've made this class because it's a wonderful class to get yourself into the habit and into the world of mocking and unit tests without having as much overhead as something like the Apex Common Library and the Apex Mocks Library. So with that said, what the Universal Mocker class does is, and what all these other classes will do, is they use the Salesforce stub API. And what that allows you to do is essentially, through the use of the stub API, create fake versions, or kind of like mocked versions, right? Fake mocked versions of your classes and their method calls and responses, right? Kind of like we did for the call out to the external system, that REST call out mocking that we did. It's the exact same thing, except for we're faking it within our own code base now, instead of we're faking it as a call out to an external system, which is pretty cool that we have that potential. So the first thing you'll want to do is get one of these service classes like Universal Mocker here, which is available on Suraj's GitHub, free to everyone, which is wonderful. I'll put a link to that in the description. And then the next thing that you're going to want to do is actually take a little time in your class that you are wanting to mock, or you're wanting to do this unit testing on. Because you have two ways in which you can fake your interactions with these different things. One of them is to use the factory pattern, which is a lot more complex. And again, if you want to go down that route, I have a whole series of videos on it. Can't cover it here. It's way too much. But if you want to go down that route, it's extremely powerful. The second one here is a little bit less complicated, and we'll still get the job done. And what it is called is dependency injection, which sounds like a really complicated thing, and in reality, it is not so complicated. And basically, all it means is all of the classes that you need for your class to run appropriately all the classes that it calls or instantiates need to be passed in through its constructor. And so that's what you kind of see here is we have this class called query cases and another class called DML cases. And in the constructor, in the test constructor anyway, what we do is pass in those dependencies. And through the use of dependency injection, you can then use the stub API or your mocking class to send in fake versions of the classes that your class depends on to run. In our case, case query, case DML. And what this will allow us to do is essentially mock all of our transactions. So now that we've got this dependency injection set up here, by passing this in, and you can kind of guess, right, by the name of the classes that I'm doing all of my querying in the case query class, and I'm doing all my DML, like my inserts, updates, etc., in my DML cases class. And we can even see that if I went and open them up. But then over here in your actual test for these classes, what you're going to do is basically build fake versions of your data. So you're going to essentially create data that is not real for your class to interact with, for your test to interact with. And then you're going to mock your class, mock your call out to a particular method, and then create a stub or a mock, essentially, version of that class. And what this does in the background is it allows you, it creates a fake version of your class and a fake call to your method that you can then pass in through dependency injection to this class here. And then you'll have these fake versions of the class to interact with that will return you fake responses so that you don't hit the database and you don't hit your other classes that you depend on. Right? You're just testing the class that you care about and the method that you are trying to test at that moment in time. So the gist of it is, to do unit testing appropriately, you need mocking. And what mocking provides you is a way to fake your calls to other places, right? Fake your calls to other classes. And then through the use of dependency injection, you can see we've got this fake stubbed version of our case query class that we're passing in, and our fake version of our DML cases class that we're passing in. And so now if we went back over here after when we run this test, when it calls case query.selectCases, it's going to be a fake version of it. We're not actually going to call out to select cases, that method, to do a query to the database and return us data. Instead, it's just going to have a return value for our code to use in this test in particular. And same thing here for update cases, right? And I know I'm going over this relatively fast, and I know I am not going in ultra deep depth here, but I just wanted to give you a really high overview of kind of what it takes to get yourself to a place where you can unit test and to get you maybe interested in actually pursuing it, because I can tell you it will make your life so much better as a developer. I pushed it off for far too long, thought it wasn't worth my time, thought it was way too much effort, and it really, as you can see, isn't crazy. It might look crazy, it's not that crazy, and it will speed up your tests and make them so much more accurate. You can accurately test pretty much any exception you can think of, by the way, with mocking, which is huge, because accurately testing exceptions with integration tests is basically impossible in a lot of scenarios. So, especially in like record locking scenarios and things along those lines. So, if you're interested in mocking, then there's a follow-up video to this one that I made 2 years ago that I'll link up above, and you can go check that out and get really in-depth information about mocking, unit tests, everything you'd want to know. But for now, I think we've covered enough. This is probably a pretty long video. I don't know how long, but I'm pretty sure I'm pushing an hour at this point. So we're going to call it quits for now. I hope that this has been beneficial to you. I hope that it's made test class creation a little bit easier to understand, and giving you the tools to make some really good tests that you can trust to make your life as a developer so much easier in the future. So, thank you so much for sticking with me this long. I appreciate it, and I'm going to get out of here, so I'll see you next time.